fairly certain that one of the very first things a practice math competition competitor would notice would be the difference of two cubes factoring result. And again, we're supposed to evaluate x cubed minus y cubed. And most people realize if you've seen this kind of stuff, you're rarely going to try to directly find x and y and substitute in here. There's an algebraic way to get this evaluation, meaning a way to produce a number here. And it's kind of amazing. You don't have to solve for x and y. You can get x cubed minus y cubed because you notice the nature of the exponents here. And of course, this super well-known result. The difference of q cubes formula, x cubed minus y cubed is equal to the quantity x minus y times x squared plus xy. And this is kind of a little bit of a telescoping experience right over here, folks. If you think about telescoping series, how things cancel out here. I remember when I first saw this in high school, I thought, wow, where did everything go? You know, but notice here that you do have minus xy squared from here to here, and then you have plus xy squared right here. Okay, so you see you get, again, you get minus y squared x right here, and then you get the same thing happening. You get a cancellation when you with the other term. Okay, there's a minus x squared. No, what I'm saying is there's a minus y squared x term and a plus x squared y term. Okay. Okay, so let's move. Oops, I made a mistake right here. That's no wonder I was getting confused. That should be y squared. Okay. Okay, that's y squared, folks, right there. My bad. And again, back to what I was yammering about. Right here, you get a minus y squared x term. You need these two guys give you minus y squared x, and this term here gives you the plus version of that, and it cancels out. So it telescopes in that kind of sense, okay? Now we are interested in that because those two exponents appear right here. Now, so let's get busy. Now this is the killer linkage here is having 13 here, and then 13 is the base right here. And so you get a very clear substitution right here, folks. In fact, just to make sure I'm making sense, this x minus y, just take a look at this x minus y. It's this x minus y right here. And 13 just became this big glob of stuff right here. The square root of 15 raised to the exponent x squared plus xy plus y squared. Okay? So that's what's going on here. So it actually ends up being quite simple because the problem's designed to work. Now, going from this step to this step, you're just taking advantage of the fact that a to the m, again, this is just a very standard exponent property. And this is why one of those properties of the logarithm works, where you bring the exponent around to the front. So this is the reason. And this is easy to remember because you have n copies of m copies, which is n times m copies of a. Okay, so that's exactly what happened going from this step to this step. Okay, now, and again, we know that the product of these two expressions, oh, I need parentheses right there, don't I? Sorry. Yeah. Need parentheses right there. Okay. Now that product, as we've seen, is just x cubed minus y cubed, and we are trying to figure out what x cubed minus y cubed is. Notice that this is equal to 15 squared right here. Okay, but it also is equal to the square root of 15. And I like enveloping this thing in parentheses to the fourth power, right? Since the square root of 15 times the square root of 15 definitionally is 15. So right here, we're at a position where we can equate this exponent. Since the exponential function is 1-to-1, if it's not a 1-to-1 function, you couldn't do this, all right? But we can equate these two guys and we get what we're looking for, which is x cubed minus y cubed is equal to 4 without having the faintest clue what x and y are. Very interesting in my view. Okay. In fact, I don't even have the faintest, I couldn't come close to figuring out what x and y is. Even if you tried logarithms on this system of equations, I don't know what would happen really that would make my life any easier here. But again, because the problem was rigged, so to speak, you have these common constants, and the common, this is on the right-hand side, this turns into the base over here. This constant term turns into the base, and then you get the very self-evident substitution. And then coupled with this law of exponents, you're home free. So that's it, ladies and gentlemen.